Hey, what's up everybody? I'd like to welcome you to another CMajor tutorial. And in this tutorial, we're going to take a very big step and build our first audio plugin using CMajor. This is going to be a two-part tutorial. And in this first part, I'm going to show you how to start getting sound out of your CMajor patch, and we're actually going to start writing some CMajor code, and I'm going to show you some of the basic parts to doing that. And then in the second part of this tutorial, I'm going to show you how to build a very basic user interface using JavaScript, CSS, and HTML. Just a reminder that we have a very active CMajor discussion group that happens on our Audio Programmer Discord, and we would love for you to join us. If you're curious about how to write code using CMajor, you can join us on theaudioprogrammer.com/community. I also have a GitHub repo where you can follow along with the code and be able to modify it as you'd like, and I'll put that in the video description below. And with that being said, let's go ahead and get started. So the way I like to do these tutorials is I actually like to start projects from scratch, especially when we're first starting with learning a new concept, and it gets us into the workflow of what we need to do to create a new project. So I'm just going to create this folder on my desktop. I'm going to call it My First CMajor Plugin. I'm going to create that, and then I will just open that, and that'll put me into this directory here in my Explorer window. And now what I can do is I can hit Command-Shift-P, and that will bring me to my command screen. And what I can do is I can create a new patch using the CMajor extension. So you need to make sure that you have the CMajor extension installed. If you don't know how to do that, watch my previous tutorials and it'll walk you through how to do that. But there's a command called Create a New Patch. I'm going to just hit Enter here. And it asks me if I want to create it with or without a GUI. I'm going to go ahead and do this without a GUI. And now it's asking me to name the CMajor patch, and I will just call it the same thing as I called the folder, My First CMajor Plugin. And I will hit Enter. And now we see two files here. So these are the two files that I've discussed with you in our last tutorial. So the CMajor patch is an overview of what you want to call the plugin and so on. I'm just going to leave that blank just for now. I'm not going to change anything. And then for the CMajor file here, I'm actually going to take this default code and I'm going to delete it. To create our first CMajor plugin, we need to know about four concepts that we're going to talk about today: graphs, endpoints, nodes, and connections. So to help explain some of these concepts more visually, I'm going to turn to another language that I'm sure some of you are familiar with that actually has a lot of similarities to CMajor, called MaxMSP. So in this MaxMSP patch, we have three processes. We have a sine wave that's going into a level meter that's going out of our speakers. And this is actually what we're going to be building using CMajor today. And I'm going to show you these concepts in MaxMSP and essentially how we transfer those into CMajor code. The first term that we talked about was called a graph. So a graph can be a very complex concept to explain, but for now, let's just keep it simple and let's say that a graph is just everything that's contained in all of this process. So the sine wave, the level meter, and the output to the speakers are all part of our graph. In a way, you can think of a DAW as a very large signal graph that's doing all of these processes and doing different things, mixing and using plugins, and then it's all going out to an output. So a DAW is actually a very large and very complex signal graph, but this is one of the most basic examples of what a signal graph looks like. So the way that we create a graph in CMajor is by using the keyword graph. And I need to give the graph a name. I will just call it My First Plugin. And every CMajor patch needs to have a main declaration inside of it. Main is something like what you see in C++, where every C++ project needs to have an int main function. So it's something like that, but for people who may not be familiar with C++, I would call it just something like home. It's where everything comes together, okay? Where everything comes together is a great way to describe it. And the way that you do that is by using these two brackets declaring the keyword main and then closing. And then what I need to do is create the curly braces to make this like a function. And now we have just created a graph. Okay, so the next concept I'm going to discuss is called endpoints. So you can think of endpoints as access points or as inputs or outputs. So here in MaxMSP, and as you can see, I had to switch the sine object out for a cycle object because I just remembered that cycle is actually the object that you need for a sine wave. So this is a sine wave that's going at 300 hertz. But if I wanted to change the frequency of this sine wave, there's a endpoint that's defined here when I hover over it, and it's very small so you may not be able to see it, but it actually says frequency. So if I wanted to change the frequency of this sine wave from 300 hertz to 440 hertz, I could do that using this endpoint. Okay. Another endpoint is the actual output from the sine wave object that goes into the endpoint of the gain meter. So the input of the gain meter is also an endpoint, and then we have outputs or endpoints from the gain meter that are going out into the speakers. But one thing that's not really defined here in MaxMSP that you would need to declare is the actual level of the gain meter. Okay, the gain slider. That also needs to be declared as an endpoint. And the reason for that is that CMajor only exposes its endpoints to the outside world. Okay, so if you wanted to connect a user interface to CMajor, the only thing that user interface would be able to see inside CMajor is the endpoints. So that's where you actually declare your parameters. So things like the frequency of the sine wave, the level of the gain meter, those need to be declared as parameters or as endpoints within CMajor. So more abstractly as well, the graph needs to have a endpoint which goes out into the speakers. So here, we see that the level meter actually has this endpoint that's going out, but more abstractly, what happens is that the graph needs to have a declaration of an endpoint that's going out into your sound card that's declared as an endpoint, and I will show you how to do that now. Okay, so let's get started creating our first endpoint. And the endpoint that we're going to create is for our graph. So as I said before, unless we declare endpoints that define the access points of what we want to come in and out of this graph, we have no way for anything else to interact with our CMajor code. So if you have a user interface that's trying to interact with some parameters to control some parameters that you may have in your code, or if you have a signal that you're trying to get out to your sound card, the only way that we can get that out or in is using endpoints. And in this case, what we're going to do is we're going to create an endpoint for our graph that's going to go out to our speakers. And the way that we do that is using the keyword output. Okay, because we're outputting a signal from the graph. So something's going to happen inside the graph and we're outputting it into the sound card. Now, there are 3 different types of endpoints, and I'm not going to go into those today because that would make this tutorial too complicated. I'll cover that a little bit later. But one of those types is called stream, okay? And it's a stream of numbers, a stream of whatever you want it to be. In this case, it's going to be a stream, and we need to declare what type of stream that we're going to make it. And in this case, it's going to be floating point numbers. Okay, so people know that when you look at a wave and a DAW, that wave is actually a collection of numbers that are giving instructions to your speakers of how it needs to move forward and backwards. Okay, and that's what we're doing, is we're actually creating this output that's going to go into our sound card. And now we just need to give this endpoint a name, and I'll just call this out. And now we have created our first endpoint, which is an output of streaming floating point numbers that are going out to our sound card. And we're going to define what we want to do in this graph that will be next. Okay, the next term that we're going to talk about is what's called a node. So a node I would define as a process. So in this case, it is some type of algorithmic process. So this sine wave that we've created here in MaxMSP, this is a node. And also the level meter is also a node. So now what we're going to do is create two nodes, a sine wave node and a gain node that are going to be part of our graph. So now we're going to go to the CMajor documentation and figure out how to use some of CMajor's built-in DSP objects to start creating this. So as you can see, CMajor has this standard oscillators sine or STD oscillators sine that we can use that will create a sine wave. And what we need to do is just define what type of frame type that we use. In most cases, that's going to be float. And we also have a default frequency that it would start with if we didn't define this, which would be 440 hertz. Okay, but we don't actually even need to use this parameter because we see that it has this default value if we don't do anything or change it. Okay, so the way that we're going to do this is we're going to declare the keyword node, and I will just call this OSC for oscillator, and we'll put the equal sign, and now we will just declare one of these objects. So a stud oscillators sine object. So we go stud oscillators sine with a capital S, and then we just need to tell it what type of frame type that we're going to use. And like I said, in most cases, at least starting off, we're going to be using a float frame type. And now we have created a sine wave oscillator. Now let's do the same thing for the gain node. So I've created another node object. I have the documentation in front of us here that has this stud levels smoothed gain. So there's a couple different types of gain in here, and we're just going to use smooth gain for now. Same sort of thing. So we have to declare what type of frame type we're going to use, and that it has a default value. If we want to use a different default value, then we could do that, but I will just leave it here. And so now we will do the same thing here. So I will call this gain, and this equals stud levels smooth gain. And once again, this is a float type. So now we have created two nodes. Okay, so the last term that we need to discuss and define is the keyword that's called connection. So here in MaxMSP, we have a connection that's happening between the output of the sine object that's going into the input of the gain object. So the connection is literally these wires, okay? And that's all that we need to do, and we're going to show you how to do that in CMajor now. Okay, so before we can make any connections, we need to know what connections are actually available to us. So here, if we go back to the documentation for the sine object, we can see that we have two endpoints that we can potentially use. So we have this output, which is how we get the output of the sine wave into another object, whether that object is our main output or whether it's the input of the gain node. And then we also have an input that we can use here that we can define a frequency. So if we want to change the frequency of this sine wave, we can do that using this frequency in, and we will use that as an endpoint in just a moment. But let's go over for a second to the smooth gain object here, and let's look at those endpoints. So we have an output that is a stream that we can put into our main output, and then we also have two inputs. We have this volume, and then we have the input where we will take the output of the sine wave and route it into the input of the smooth gain. Okay, so let's just go ahead and do that here. So the way that we make connections between endpoints is using the keyword connection. So what I could do is I could create a connection. And so what I want to do is I want to go from the sine oscillator out into the in of the gain, right? So we have sine is producing a sine wave, and now we want to take it out of the sine wave and route it to the input of the gain. So what I could do is I could just say OSC dot, and now we have the output stream, which is called out. So I can say OSC dot out. And then what you do is you just use this little arrow here to define how you want to route it. So OSC out, and now we go over to the gain. We need to look at what the endpoint is called for the input, and that is called in. So I can say gain dot in, and then I put a semicolon there, and then I can go from the gain into our main out. And the way that we do that is we could declare another connection, and we'll do gain, and now we want to see how we output from the gain. So we have this output stream called out. So we do gain.out, and then once again the arrow sign just to show where we're routing that connection. And now we want to go to our main speaker, which is called out. And now we should actually hear something. So the way that we actually run this C major patch is if you press on Mac Command Shift P. I imagine it'll be something similar on Windows. Then you go to Run Patch. Okay. If you try to click this arrow here that's on the side of that, won't work. Okay. So that's how you need to run this from a C major patch. So you may want to, if you're listening in headphones, you may want to turn it down because it's going to be the sine wave is going to be at full volume for now. Okay, so I'm going to just click Run Patch, and here we go. Okay, you should have heard something coming out of your speakers. It actually showed in a different window for me, but here it is. Here's your C major patch. Okay, so that's what should happen when you're running this in VS Code. Okay, so if I want to start, and I just hit stop audio there, but if you want to start the audio again, you can start it. I'm not going to do that because that may be a little bit loud for you, but you'll see some useful things here in the in this window, which is pretty cool. So we see that there's one output channel. Okay, if we wanted to change that, then we could change that if we wanted to. And then here we don't. Here's our plugin actually. So we could run this in a DAW if we wanted to. I showed you how to do that in the last tutorial and in the first tutorial, but so I won't show you that again. We'll just run it here within the VS Code window. But at the moment we don't have anything because we haven't declared any other endpoints. Okay, so in order to have parameters that we can control, we need to declare endpoints. Then here we have a section called inputs, and we see that there are no inputs, right? Because we don't have any input endpoints either. Another really cool section that I think you'll find interesting is you can click here on graph, and here you'll see your kind of max MSP-ish type of routing here. So you can see that we have we have two nodes here, which is gain parameter and OSC. Oh, I don't know what I did there. I think it must be if you click on that, that brings you back to the code, which is quite cool as well. But anyway, the OSC, the output of that is going into the input of the gain parameter, right? And then we have the output of that that's going into the actual main output. So you can see the signal routing there. And for people that really want to get into the weeds, you can actually generate C++ code from this, or WASM, or LLVM ARM64 if you want to take this sine wave patch and put it onto some hardware. So really, really cool stuff, very useful for debugging, really cool stuff all around. Okay, the last thing that we want to do is we want to create some parameters that we would like to actually be able to affect the sine wave or affect the gain node if we'd like to. And in order to do that, we once again need to come back to create endpoints. So here we have these endpoints that are defined. At the moment we're looking at the smooth gain endpoint, and now we have this this endpoint that's called volume that allows us to control the volume. So the way that we can do this is we can go over here. Now what we need, instead of an output, we need an input endpoint, right, which is going to be an input into our node called gain. So the way that we define an input is, of course, using the keyword input. Okay. Now the way that you create an endpoint using one of these nodes is you just declare the object that you've created, which is gain, and then we just declare the endpoint that we've used, which in this case is volume. Okay, and now we've created it. Now what would be nice is if we could define some default values for this, right? So we want to know what the minimum and what the maximum value is, and maybe an initial value. So the way that we do that is if we go back here into patch format, let's see if it's here. These are the keywords that we can use to help us define some minimum, maximum, initial values if we want to create how the values step. So whether that would be 0.01 or 0.1 every time that we're turning the parameter control, we can define that here. There are a whole bunch of different fields here that we can define if we want to. Okay, if we wanted to make it dB, we can do that. I won't do that for now. I'll just keep it super simple. But this is essentially how you can define what you want that endpoint to look like. So here we have input, gain, volume. Now the way that you actually use these fields, these patch parameters, is once again using the double braces syntax, and then you just use your keywords here. So here I'm going to define a min, a max, and an initial value. Okay, so here I will do a min. One thing that they should probably clarify in the actual documentation is that this is in decibels and not in just raw gain value. But I know from doing this before that we want this in decibels. So what I'll do is I'll give this a minimum value of 84.0. Then we do comma, a max value I will put at 6.0, and then we'll make our initial value, let's see, minus 2.0. Right, and we just make sure we put a semicolon at the end there. And now let's create another input where we control the frequency of the oscillator. So once again, this will be input, and then we do our oscillator object. Let's go back there, see what our endpoint is there. So once again, we see there that our input is frequency. That allows us to control the frequency there. So it would be osc.frequency in. And then we use the double braces syntax. Now we'll declare our minimum at 20.0, our maximum at 20,000.0, and we'll create our initial value at 300 hertz. Okay. And then now we put a semicolon at the end, and we should be good to go there. So now let's see what happens. So if all of this is working correctly, then we should see two parameters that show up, because CMajor has been nice enough to create a generic user interface for any endpoints that have been created. So once again, it's Command Shift P if you're on a Mac. I imagine it would be Windows key, Shift and P if you're on Windows or something similar. But here we go. So we're going to hit Run Patch. And here we see that we have an error. Okay, so something has happened, and we see that we haven't defined max here. We just have the value, but we haven't actually declared it as the max value that we want. So here we just need that keyword max, and then now we hit Run Patch again. So now we can see that we have our CMajor patch, and here's our plugin. So if we wanted to take this and we wanted to drag and drop it into our into a DAW, then we could actually do that. If you wanted to export this to a Juice project, you can do that to create your own plugin. That's essentially how to do it. And then once again, you see the output there, and we can take a look at the graph. And now we can see that our graph has the frequency in, and that is routing into the input of the gain parameter. So if we wanted to take a look at our signal graph, we could do that, and that's how we do it, right? So there you go. That's essentially your first plugin there. So now let's do. I'll give you one little tip here that will help simplify this code to wrap up. And what we could do here is we could actually do things like this to help simplify our code. So the CMajor team, big shout out to Jules and Ches, they have made it where you can actually put your inputs together and just declare them once like this. So if I just take this and I put it inside here, so I can make it where I just need to declare the input keyword once and just put it all in there. Same thing for node. Okay, so I'll do node. And so our node, our gain. Make it all nice and neat. And the same thing for connection. So we could do that for our connection as well. I think you could actually probably just do something like this if you wanted to, which is take this, and you might be able to just define this all in one line. Okay, get rid of those connection keywords, and let's just run the patch again, make sure that we're good to go. Let's run patch. Okay, and that doesn't work, unfortunately, so I think maybe it just needs to be like this. Okay, so try to run it again. I thought we would be clever and be able to do all of that. So great. So there you go. I hope you enjoyed this tutorial. As I said before, what we'll do is we'll put this on our GitHub so you can walk through and just change the code as you'd like and get familiarized with it. And in the next tutorial, what we'll do is we will do a custom user interface, just something very simple just to get you started. And I hope you enjoyed this, and see you next time.